I want to talk about large language models, this artificial intelligence technology in its infancy, how we're using it, what we as humans do with language, and why I think we're on a major alteration of course in human history in a direction of massive accelerated growth and exponential development in science, technologies, human knowledge, etc. It's going to be the most profound, changing thing of all of human recorded civilization. This whiteboard represents this part right here. We're going to call it all of the whole entire universe, everything that is out there, all the way up until this point right here. Okay? The whole universe. This point right here is our human apparatus, our bodies. And in here, this is our brain. Okay? Brain, we experience the universe through our sensory apparatus, but we extend the sensory apparatus with technology, with devices. We can't see x-rays, so we create devices that allow us to extend this so we can perceive more of the universe. So we're going to make a line right here, because what we do in our minds, what we perceive, is a subset of our theoretical technologies that extend, that allow us to gather more information. We're going to leave this open because I'm going to grant the universe maybe has some more than our theoretical technologies are not going to be able to detect. Okay? That's over there. But this area right here is what I really want to talk about. What are we doing? We take this extended information that we get, an x-ray. Well, we can't see an x-ray. We can't experience the x-ray directly. So anything of this extended area that our apparatuses give us, it is translated right here to some point by some method to something that we can interpret and experience. So in terms of an x-ray, like a radiograph that allows us to depict like bone, so we use our visual senses to interpret, because the technology reduces it to a way we can experience or interpret this information that's out here of the external world. Okay? This extended area of information. What do we do with it once it gets into our brain? Well, we create words. And in this depiction, words are going to be demonstrated as nodes on a network. So we have a concept that we want to convey, talk about behavior, properties, etc. We create a word to describe such a thing, and the edges on this network represents the associated relationships to other words that we have in our vocabulary as we're trying to communicate and describe the meaning of things. And then we use these words in combination with other words that are related to other words in this vast network of words. Okay? That's what we're doing. That's what we do. All of science, unless it's understood telepathically in some kind of non-symbolic way in somebody's mind, it's reduced to the communication that we do understand, which is words. We're describing the things with terms and meanings, etc. Not all networked associated words that we can devise in our brain map or have any kind of mapping of the external world. Some we create, like the big purple elephant drove a Ferrari and then parked it on top of a casino in a cloud. Makes no sense. It's just nonsense. This thing that we just created doesn't map anywhere on the external world. Okay? Other areas, it does map. Force is equal to mass times acceleration. We could describe the external world using networks of associated concepts, Newton's second law in that case, right? And then this could map on the external world. Mathematics being a special case where we have defined accent, very rigorous definitions, very strict relationship laws and rules, and we build a whole network of mathematics and create theorems, and this thing just generates its own thing off into topology and differential geometry and algebraic blah, 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 whatever. Math, right? Some of that stuff in math, this is the math network, some of that stuff maps, some of it doesn't. What is a large language model doing? Large language models, in their infancy, with how they're being utilized, is already solving open problems in mathematics. You can't ask a large language model, hey, create this social networking website, create this whole code for this whole complicated structure. It won't do it. Right now, it codes very well, but you have to ask it incrementally. Give me this block of code. Give me this next block of code. Refine that code to do this. Refine it just a little bit more to do that. Okay, let's move on to the next block of code. No different than in mathematics, how they're solving open problems. But let's take it a step further. We are on the verge of the refinement of this technology that it's going to generate, which it could already, in a very small way, it generates new concepts, and it creates new associations, relationships to already the words in this massive database, okay? Could create new concepts, new words to describe new associated relationships. It's already doing it. It's going to get to the point very shortly where it can just run. You can just, hey, build a whole new area of mathematics from previous known areas, new theorems, from material science, make connections and associations for this material to do this, create hypothetical experiments or practical experiments to devise this or to get this outcome. Because everything of the external world is reduced to, if it's mapped well, a network of words. What is a large language model able to do? Understand our network of words and build on it, and potentially build on it and build on that thing that it just previously built, and then build on that, and then branch off into multiple, infinite, possibly, right, networks of all kinds of different associated meanings, etc. And it's just a matter of how well are they mapping. And it's not hard to theorize that we further improve these models to constrain themselves, to really focus on types of networks that are that do a better job with mapping or more realistic. So then we could reduce some of the branching in the physical sciences to networks that actually do a better job of mapping. What are we getting at? Large language models, where they are right now, are already solving open problems in mathematics with helps of mathematicians. We're a few years away for them to generate whole new areas of science, whole new material technologies, computational technologies, computer technologies, physics, results, all on its own. This AI does not require sentience. It doesn't require self-awareness, personhood, desires, intentions, etc. The AI of what it's doing right now with the associated network of words, a little bit more advancement and refinement is going to bring us to that next step of accelerated and exponential growth of human technology. That's what I wanted to share with you. If you have any questions, let me know. Otherwise, I think that's where we're at, and it's very exciting because the future, we are in it. We are in the sci-fi future. We're walking through the door, so to speak, of sci-fi future. So it's very exciting, and I think we're going to have this unpredictable, massive growth that is on the horizon, and we're getting closer and closer to it. So yeah.